Water system design process. There are three basic design configuration for distribution system. First is arterial loop system. Second, grid system. The last one is tree system. Arterial loop systems are distribution system with a complete loop of the arterial mains around area being served to minimize these ends. Future arterial loops system include large diameter mains around surface area. Second, water supplied from four directions, which means pure fire hydrant and intersections and open fire hydrant up while would be coming four different directions to supply that hydrant. The last one is good flow throughout system. The next type of system is the grid system. The distribution system layout in which all ends of the mains are connected to eliminate these ends. Some features the most of water mains are interconnected, reinforced with larger arterial mains. And the last one is flow usually goods rather in a main are 6 in or more and your drop flow from 2 to 3 directions. The last one is tree system. A distribution system that centers around a single arterial mains branches are the take off the right angles and have dead ends. Here's the description. Transmission line delivers water to an area. Second, distribution mains branches are not connected and this result dead ends ultimate result in a poor water quality. Dead ends means longer than 1000 feet should be at least 6 inches in diameter. System valves. Isolation valves are required to allow for system isolation for maintenance or repairs. This valve should be spaced periodically so that small sections of the system can be isolated and there a problem requires a shutdown lasting more than a few hours. Water mains less than 12 inches in the diameter should have isolation valves within 1000 feet of each other. Valving. All branches of the arterial mains should have isolation valve as well. A situation where mains intersect in a grid at least two, but preferably three isolation valves should be installed. Air relief valves should be installed at system high points to the release area that has come out of solution since this can reduce system flow. Back prevention devices should be installed to isolate the system from potential contamination sources. Water main size requirements. The carrying capacity of a water main is determined by its size. Water mains must be sized to meet peak demands from the domestic, commercial, industrial, and fire protection uses. They must be able to deliver adequate. First is quality, second is quantity, third is pressure, the last one is velocity. Quality. One of the primary goals of the distribution system operation is to maintain good water quality throughout the entire distribution system. The design of the system impacts the operation and maintenance procedures required to maintain good water quality. Arterial loop systems are preferred to grid system, which are preferred to tree system. Second one is quantity. Domestic use requirements can be determined by either referring to past usage records or from general usage figures for the area. Fire flow requirements are usually the determining factor for the system size in communities with a population of 50,000 or more. Fire insurance underwriters recommend that no main in the distribution system should be less than 6 inches in the diameter. Third is pressure. 35 psi at all fire hydrants is the minimum pressure able to meet fire flows areas. In areas requiring high fire flows capacity, residential pressure is typically kept in the 5 to 75 psi range. Commercial distinct pressure is the 75 to 100 psi range. Although customers want good water pressure when they turn on the faucet, excessive pressure can damage fixtures and water up appliance. High water pressure will also contribute to more leak in the description system. The last one is velocity. Flow velocity should be limited to 5 feet per second in the distribution system to avoid friction losses during the normal operations. Water velocity are reduced by increasing the diameter of the pipe for a given volume of flows. Systems are designed to provide a flow velocity of between 2 feet per second and 4 feet per second during the maximum flows.